Hello everyone, welcome to this presentation. My name is Yongfeng. I am an assistant professor at the Saskatchewan Ministry of Agriculture, endowed research chair in carbohydrate quality and utilization. I work in the Department of Food and Byproduct Sciences at the University of Saskatchewan. Today I'm going to share with you some of our recent research on faba bean starch. I will start with the overview of the use of faba bean in the post industry. After that, I will move to granular and molecular structures of faba bean starches isolated from 5 varieties. In the end, I will share with you the functional property of faba bean starches, and I will compare them with commercial pea and maize starches. As one of the main post crops, faba bean has been used in the market in North America for a long time. Nowadays, one of the main ways to use faba bean is still in the feed industry. Different forms of the faba bean, including whole seed, meal, and the starch and the protein fractions after air classification, they have been used for feed formulation. And the feed products have been fed to pig, ruminant animal, poultry, and fish. In most recent years, there is a growing interest in utilizing faba bean in the food sector. In the market, you can find the whole faba bean seed. They have been used for the production of the canned food. And you can see different names in the market. For example, broad beans and the fava beans. Basically, they are the same thing. Have the same meaning as a faba bean, but just the same thing with different names. Faba bean have also been milled to produce flour. Like this company, they produce the faba bean flour, or we can call it a faba bean flour. There is also an increase in volume of a faba bean used for fractionation to produce functional food ingredient. Both dry and wet methods have been used for this purpose. In a dry method, faba beans are typically dehulled, pre-milled, and air classified to produce starch-rich flour and protein concentrate. In a wet method, the faba bean seed can be fractionated into isolated starch and protein isolate. Compared with the ingredient from the dry method, isolated starch and the protein isolate, they have a higher purity. Why faba bean have attracted increasing attention from the food sector? Let's take a close look at the proximate composition. So when we compare the faba bean with a pea, so the faba bean usually they have a lower starch content, but they have a higher protein content than the pea. For the protein content, most of faba bean they range from about 28 to 31%, but that of pea range from 20 to 27%. There is not a big difference in the non-starch polysaccharide content. So I can share with you the main reason why the food industry we are interested in fractionating the faba bean into a different food ingredient is because of the higher protein content of faba bean, because there is a growing demand for plant-based protein from the food industry. But another thing I want to call your attention is, despite the higher protein content, faba bean still has about 40 to 45% of the starch as the main co-product. So the post-processing industry, they are still facing the challenge of finding new ways to utilize the faba bean starch. Like many other crops, there are also some challenges of using faba bean in the feed and the food industry. First of all, faba bean they contain the anti-nutritional factors. Some of them are common in pulses. including inhibitors of digestive enzymes, tannins, lectins, and the fatty acid. But some of them are unique in faba bean. Good examples include vicin and convicin. Because of the presence of these substances, human subject deficient in glucose 6-phosphate dehydrogenase, after they inject the faba bean, they will develop a condition called favism. One very typical symptom of this condition is known as acute hemolysis. Because of this, severe health issues, the utilization of faba bean in the food, particularly for the human consumption, has been hindered. Another challenge of using this post crop in the industry is the large seed size of certain varieties. As we can see in this image, some of varieties like the snowbird and the snowdrop, they have a seed size similar to that of field pea. But some of variety like this one, Malik, the seed size is noticeably larger than that of field pea. So if we want to use the equipment commonly used for the seeding and also processing of field pea, when we try to use the same equipment for the faba bean seed with the largest size, we need to do some modification. So which means there will be some extra efforts when we try to plant the faba bean with the largest seed size. And another issue associated with this is the higher seed cost, because for the same acre of the land, when we try to plant the faba bean with a larger seed size, which means we need to buy more seeds for planting, because usually the seeds are sold by weight, not by the number of the seed. In 2018, we as a group of researchers in Western Canada, we started working on a project to develop effective strategies to add value and to enhance the industry utilization of faba bean. This project is funded by Pol Science Cluster of Agri-Science Program. We have Dr. Janita Wanasandra at Agriculture and Agri-Food Canada as the PI, AAFC. So we have the researchers from AAFC, we have researchers from University of Saskatchewan, and also we have two industry partners, Dr. Mehmet Topik from AGT Food and Ingredients, and Chris Chavello from WA Grain and Pulse. So the whole team, we work collectively to develop new food ingredients from this important post crop, including starch, protein, and fiber. In the end, we're also going to look at the sensory attribute of the new faba bean-based food ingredient. Today, I'm going to share with you some of our most recent progress in the starch part of this project. For the starch part, we received the faba bean seeds of 5 varieties from 2 years, 2015 and 2016. The 5 varieties included Snowdrop, Snowbird, Tabor, Fabel, and Malik. They are different in seed size, in tannin, and also vicin and convicin content. For example, the Snowdrop and Snowbird, they have small to medium seed size. And then the Malik, as I mentioned before, they have the large seed size. Regarding the tannin content, the Snowdrop and Snowbird, which have lighter color in the seed coat, they have a low tannin content. With respect to the vicin and convicin content, most of varieties, they have regular content of these substances, but Fabel, it has relatively low content of these two anti-nutritional factors. After we received the seeds from 2 years, we use a wet method in our lab to isolate the starch from the seed. Despite the reported difference in the seed morphology, and actually the isolated starches from these 5 varieties of faba bean, they show very similar morphology. They show the characteristic kidney shape or in a granule, and some of them have an oval shape, as you can see here, and some of them have the spherical shape, and some granules, they have an irregular shape. And we also include a commercial pea and the commercial normal maize starch in this study. What we found was the commercial pea, the granular morphology resembled that of the faba bean starches, but the commercial normal maize starch, the granular morphology was distinctively different from that of all the 6 pulse starches, and also the commercial normal maize starch, it had smaller granular size than the 6 pulse starches. We determine the X-ray diffraction pattern of all the starches. All the pulse starches, they show a C-type X-ray diffraction pattern, which is known to be a combination of A and the B-type polymorphs. And then for the normal maize starch, they had displayed the typical A-type X-ray diffraction pattern. We also measure the percentage crystallinity. Most of the pulse starches, they show slightly lower percentage crystallinity than the normal maize starch. Normal maize starch has a percentage crystallinity of 31.6%. Regarding the average particle or granular size, all the faba bean starches, their granules were slightly smaller than that of the pea starch. But all the pulse starches, they show considerably larger granules than the normal maize starch. The average particle size or the granular size of the normal maize starch was only half of that of pea starch. One very interesting thing I want to share with you is it seems like the 2 growing years, 2015 and 2016, they did not show a significant influence on the percentage crystallinity and the average granular size of the 5 different varieties of the pulses if we compare just between these 2 years. We also determine the apparent amylose content of the starches using the iodine calorimetric method. So the amylose content of the faba bean starches range from 36% of the snowbird to about 43% of the snowdrop. The amylose content of that of pea was comparable to that of the faba bean starch. The value was 40%, and the normal maize starch, the amylose content was noticeably smaller than that of all the pulse starches. The value was 30%. Again, I just want to call your attention, the 2 different years did not show to affect the amylose content of the 5 varieties of the faba bean starches. We determine the gelatinization properties of the starch using differential scaling calorimetry. One very important feature is, seems like all the pulse starches, including the faba bean and the commercial pea starches, their gelatinization temperature were noticeably lower than that of normal maize starch. As we can clearly see in this figure, the normal maize starch it had a considerably higher gelatinization temperature than the other starches. According to this paper published in 1998, the C-type X-ray diffraction pattern of the faba bean and then the pea starch is known to be a combination of an A and a B-type polymorphs. And in the pulse starches, the B-type polymorphs located in the center of the granules, so which is close to the hilum of the granules. Because of this, the B-type polymorphs can be gelatinized at a lower temperature, which contribute to the overall low gelatinization temperature of this starch, as we can see in this figure. After we gelatinize the starch, we store it at 4 degrees Celsius for 7 days to determine the percentage of retrogradation. All the faba bean and pea starches, they show a percentage of retrogradation close to 45 and 50%. But for the normal maize starch, it only showed a percentage of retrogradation of about 40%. So actually, when we try to use the starch as a thickener or stabilizer in food system, higher retrogradation percentage or higher higher retrogradation rate, they are usually considered as undesirable, because higher percentage of the retrogradation is usually associated with a phenomenon called syneresis. As you can see in this yogurt product, the syneresis means the separation of the liquid phase from the solid phase. So this is considered as undesirable when we, if we want to use the pore starches in product like yogurt or pudding, we may need to further modify it for such application to increase its stability. We determine the pasting property of the starches using a rapid viscous analyzer, and compare with the normal maize starch. All the pore starches, they show a lower pasting temperature. This is associated with the lower gelatinization temperature of the pore starches. And all the pore starches, they show a lower peak viscosity, as we can see here, and then lower breakdown viscosity, and most of them, they show a higher final viscosity, as we can see in the profile, except for 2 samples. Their final viscosities were lower than that of the maize starch. Snowdrop from 2015 and Snowbird from 2016. So the lower peak viscosity, lower breakdown viscosity, and generally higher final viscosity of the pore starches are associated with the high amylose content, as we discussed above. We also determine the gel strength of the starches. So after we cook the starch using RVA, we store it at room temperature for 2 hours for gel formation. So what we observe is the pore starch, the faba bean starches, they form noticeably stronger gel than that of the pea starch, and then the normal maize starch form the weakest gel. So it is known the pore starches, they are desirable for the preparation of the food product like the glass noodles or Chinese vermicelli, and also the jello type of dessert in Asian market. This is related to the strong gelling ability of the starches, and currently pea starch is the main pore starch used for this application. So in this project, one of the future directions we are going to pursue is to investigate, because the all the 5 varieties of the faba bean starches, they showed stronger gelling ability. So we are going to evaluate its performance in the glass noodles and also in the jello type of dessert. And we're also interested in using these faba bean starches to prepare the biogel for non-food applications. Here comes our conclusion from this study. Compared with the normal maize starch, faba bean and the pea starches, because they are all pore starches, they show more similarity. For example, they had higher amylose content, lower gelatinization temperature, and also higher retrogradation rates. And the pore starches, they show lower pasting temperature, lower peak viscosity, and breakdown viscosity. And in general, they had greater final viscosities. With respect to the gelling ability of the starches, faba bean starches, they form the firmest gel, followed by pea starch, followed by the normal maize starch. And then the strong gelling ability of the faba bean starches is worth further investigation. Overall, the 2 growing years did not considerably affect the structure and also functional attribute of the faba bean starches of the 5 varieties, except for the pasting profiles of the snowdrop and the snowbird varieties. In the end, I would like to acknowledge the financial support from Agriculture and Agri-Food Canada, from Saskatchewan post growers, and from Ports Canada. We are grateful to Locat for providing the pea starch and to Cargill for providing the normal maize starch. I would like to thank our group members, Dr. Dongxin Li, Jiayi, and Xinjing, for their nice work on the project.